the mechanism to execute multi-threads on the processor?
Yes, up to 2 threads running at once if the processor has enough computing resources available.
Yeah, it's like it's got a single CPU and 2 integer units or whatever, so essentially do 2 integer operations at the same time, but it'll block if they both try to do floating point, for example.
Okay.
I don't remember the exact geometry of how that stuff's all laid out, but that's the gist of it.
Okay, but how does it support threading in specifically threads?
It checks to see what it's got the CPU core. It's got 2 data streams in it. It's decoded them up to X point. Looks at them. This one needs to use the integer unit. This one needs to use the floating point unit. So it says, okay, I'll dispatch both of them at the same time.
Okay.
Each going to whichever.
As opposed to your multi-core, because each core has completely independent ALUs. So you can basically send any job to any core, and they do not have to wait for each other to complete. But if you send 2 jobs to the same core, then multi-threading can try to make the best use of the ALUs by scheduling things in a semi-intelligent way at runtime.
Okay. With cache and a couple other things that can either be really fast or really slow, as between say the old Pentium 4s and the new Core i7.
Okay, understood. So in the case of a processor that has one single ALU and one single hardware ALU, that becomes a non-issue, exactly. So it cannot perform true operations in parallel, because when you have only one single ALU, as you might recall from the assembly language programming class, everything has to be done by the ALU. Okay? So in that case, the parallelism is actually just a pretense. Okay? Because you really only have one single ALU, you're only doing one thing at a time. So the question is, why do we want to do that? Why do we want to pretend to have parallelism when things are actually still being done sequentially? This picture here. Okay? We want to save the programmer, a lot of grief by being able to say that, oh, by the way, frame processing is one single function. Okay? Checking for the motor status is another function. So when you write the programs, these 2 functions do not interact with each other unless they have to. But for the most part, if these 2 are completely disjoint and have nothing to do with each other, each function does not even need to know the existence of the other function, let alone the data structure required by the other function. Question? Point? Okay. So that's the reason why we want to have a pretense of parallelism, even though in terms of hardware, it is not actually parallel in any way, at least with a simple processor that has one single ALU. Now, when you have multi-core and hyper-threading, then you really want to make use of multi-threading because you can leave it up to the hardware to decide, oh, this core of this quad-core processor isn't really doing anything, and then the kernel can send threads and say, okay, you better start to do something, to speed up the performance of the system in general. Let us consider a program that runs on the robotic system, because that's my favorite topic. To ensure reliability, it is usual that we have the following tasks to perform: maintain communication with a human interface, remote terminal by Bluetooth, whatever you want to do. Motion control, speeding up, slowing down, looking at the motor encoder, where exactly am I, at this point. Path planning, which is a higher level concept. Should I make a turn in 20 steps? Should I continue to go straight forward? Sensor reading, that's really important because you need to know, am I going to run into a wall? Am I too close to the left-hand side? Am I too close to the right-hand side? And so on and so forth. Sensor interpretation, which is kind of related to sensor reading, but interpretation sometimes means, okay, am I seeing a new wall? If I am, I have to put it into the map, and so on and so forth. Self-monitoring and diagnostics, okay, looking at the voltages coming out of the battery, because if your battery is going low, you might want to stop the robot and just flash a code to say that my battery is running low. Blow yourself up?
Run to death? Run it to death.
I can explain why you don't want to run it to death, okay? Exactly. Over-discharging a battery is bad, but there are other things that are bad when the battery is low already. Let me give you, this is a real case it happened in, actually. So this is the same guy who went to Lawrence Livermore's National Lab, after he graduated from UC Davis. But when he was in UC Davis, he was in a team that designed like a relatively large robot, probably the same size as a powered wheelchair today. But powered wheelchairs back then were not, common, so he had to, kind of put everything together using components that he's familiar with. And on that, there's a processor, to do navigation. It can actually do dead reckoning, and have the accuracy to get back to the original location. I think it's off by, some really small amount. So the encoding is really good. The motion control is done perfectly. And it is a robot they have to use, for a certain competition. So these competitions are funny. They will test the raw speed of the robot with a person actually driving it, and they will also see how fast it can kick not a soccer ball, but some kind of a ball that it has to kick, as a competition, as a contest. Okay, and this guy, designed it so it has a spinning wheel that will spin up to a high speed before the ball is dropped into the hole, into the chute, and it will just kick it out at a very high speed. Most other robots, of this, competition would just use gravity. So it will just kind of get the ball really high, and it has a little ramp, and use gravity to accelerate the ball and see how fast that can go. But this guy actually put a drum into the whole thing, spin up the drum, and then drop the ball, and then so the drum is the one that will actually accelerate the ball. And he said that he could destroy the other robots, with his, soccer ball, shooting mechanism. But anyway, getting back to the main point that I want to make. Okay, so during the competition, of having a human driver on it to try to make it go as fast as possible, and they time it, this is what happened. It is actually kind of funny, but not if you're the person on the robot. When the operator floored the gas, okay, which means press the accelerator, so it applied all the juice to the motor. The output voltage of the motor dropped below a certain threshold. Okay, and that threshold is important because the logic part or the brain part of the robot has a reset controller which monitors the incoming voltage. When the incoming voltage drops to below a certain point, it will say, oh, this is not a safe voltage anymore because the processor requires at least this much voltage to operate. When the voltage drops below that point, it is no longer reliable. I'll just hold the reset line of the processor, which basically means the processor is just being held in a reset state, which is quote-unquote a safe state because it won't be executing anything that's funny. Unfortunately, they did not design the robot with a safe interlock mechanism, so the other side, which is the motor controller, is stuck at full throttle. So here we have a problem now because when the motor controller is stuck at full throttle, the battery output voltage will continue to be low because that's how it got low to begin with. And yet you cannot get the processor to start up again to tell the relay to let go. I don't think they designed that in either. Yeah, they did not design a mechanical spark that you can just yank and stop the whole thing. No, when you're holding on to the thing does not have a seat, okay? So the operator was actually just riding on the whole thing, in an awkward position holding to a pole, okay? so when your hand and feet are just, busy just holding on to the robot so you don't fall off the robot, I don't think you have much time to think about, okay, which wire should I disconnect down there? So getting back to the answer, I cannot remember why I was talking about this. It was something that you mentioned.
You don't want to drain your battery.
Exactly. So that's one reason why it is why you have to do self-monitoring and diagnostics. But over-discharging battery is the number one way to kill a battery, because you destroy the chemistry inside the battery that way. And
you run the maze once.
Yeah, but the batteries are expensive. You don't want to ruin your battery. So anyway, self-monitoring and diagnostics is very important because you want to keep track of the temperature of the processor, temperature of the regulators and whatnot, in many, many applications. So each one of these tasks is by itself a sequence of operations. For example, the overall code to maintain communication could be something like this. While true is an infinite loop, you wait for a query coming in through a dumb terminal interface, You interpret the query, you formulate a reply, you transmit the reply, you go back and wait for the next query. Okay.